then we built our second one we called the Blaster, and it uses a facial detection algorithm to fire a shot of liquor into your mouth from 3 meters away.
Welcome to lucky episode number 7 of the Odd Engineer podcast with Will Fischer of Voxdale GmbH in Berlin. He's a mechanical engineer, U.S. patent agent, and maker of really weird custom machines.
So Will Fischer, take me back. Take me back in time.
The guy.
What is your, go back to school. What was
sure.
that? Let's start.
My undergraduate's in mechanical engineering, as plain can be, Rice University down in Houston, which I'm a Texan born and raised, and I stayed there for university as well. I stuck around for my master's degree, which I did my research at NASA Langley Research Center in Virginia on convective heat transfer and microgravity. So what happens when you are in a pressurized environment like space station and hot air needs to do something, but there's no gravity to create convective flow.
Whoa.
Anyway, it's fascinating stuff. I did the numbers and the terrestrial-based experiments to prove it. My numbers lined up, which was beautiful.
Wow. Thermo was hard enough for me, so that must be
I really enjoyed thermo. Yeah. And so that was kind of my thing. I went from there.
Wait, so what was your master's degree? Was that
it was mechanical engineering as well.
A specialty?
Despite working at NASA, it was still the kind of more general degree, which actually I'm happy about.
Oh, cool.
But I kind of, as I worked at NASA, it was not right for me, particularly in 2009. The space industry was a very uninspiring place, which of course has changed dramatically in the meantime. I would have been very happy to go into the space industry then, but the opportunity that presented itself was to be the first non-founding employee at a medical device startup. And so the two founders that were active in it for the time that I was there were still graduate students. So I was working on the project full-time before anyone else was. So while I'm not officially a founder, I'm pretty dang close.
Yeah.
So I was there 7.5 years.
Can you say what that device was?
The product is an implant for type 2 diabetes treatment. So it's 2 millimeters by 14, so about the size of a large grain of rice. It has 6 months worth of dosage inside of it. And then it has a membrane on one end that controls the release of the drug into the body passively. So it's no moving parts, no electronics, just a nanostructured titanium oxide membrane. Wow. And so we had to, when we started, no one at the company knew how to create such a structure. There was a lab on the far side of the country that did. We started to replicate their work in the lab, build a consistent process. I was the first person to grow our nanostructures. Then we had to figure out how to open the back sides of them. So spent a lot of time in the semiconductor lab at University of California, Berkeley. They have the nano lab, which I spent easily 10,000 hours in, playing around with both inductively coupled plasma etching and also a lot of time in the electron microscope.
You're really getting outside of mechanical engineering.
Yeah, I dabble. But for that we needed all sorts of other stuff had to happen. And if you're the first employee at a startup, you do a little of everything. Mm-hmm. So when we needed our own electron microscope mounts, I figured out how to make microscope mounts. And when we decided that we needed to have our own piece of equipment, this inductively coupled plasma etcher, which is the size of a Mini Cooper, it was up to me to source it, figure out the crane lift into our office building, get all the facilities in place, deal with the exhaust, figure out how to install the 75 pounds of pure chlorine gas that feeds into this thing, which is deeply terrifying. And then what to do with it after we were done with it, which is not exhaustible in its normal state. And all of that stuff. So I went from building our product and really doing the R&D on it, from there into facilities.
Yeah.
Kind of, but then of course still startup stuff. So I was still working on the product and locking in our process and that sort of stuff. And then it became, as we hired on more and more people, it was easier for me to take kind of a consulting role in the production and to build additional equipment as we needed custom equipment. So I started building custom laboratory equipment for the scientists and engineers there.
You're cute for the scientists.
Yes, and it was super fun. And the cool thing is, you know, when your customers are all, you know, within 2 minutes walking from your desk, it's so easy to go and be like, hey, is this the thing you really wanted? Okay, I'll go back and make it that way. And it's really fun. And the goal was to create a prototyping shop that could build lab equipment kind of proverbially by Thursday, you know? So if somebody came into my desk and needed a piece of custom equipment, that I had the resources and the equipment to make that within a week.
Wow.
The kind of ultra fast turnaround prototyping. And this was before 3D printers could really reliably do materials that were useful. So a lot of this conventional machine shop stuff, CNCs, a lot of hand work and stuff, and a lot of McMaster car.
Of course.
So much McMaster car. And so that was kind of really where I felt most comfortable, is in that like really fast, how do we turn it around really quickly? I say full stack, but that meant that I was doing everything from the whiteboard to the physical design, any embedded systems that had to happen there, which were almost always on an Arduino, all of the circuitry, the whole thing, the whole full spectrum. And we're not necessarily complicated or product level things, but things that had to work to do laboratory work.
That's the hardest part.
Yeah, and so, and like weird stuff, you know, somebody come and be like, all right, we're gonna put this thing in a radiation field because we gotta sterilize it, make it out of lead. Like, what? Wow. Okay, those are the rules, right? You know? And then get electronics to work from inside of the big lead box you just built.
Oh, wow.
So like goofy things. Fortunately, there were wires going through, so I didn't have to worry about Faraday cage stuff. But
right.
But yeah, like that sort of stuff were the sorts of quirky things people would come and ask for.
Well, that's a great experience.
It was super fun. I was doing a lot with piping and valving and timing. And at the same time, the DNA Lounge in San Francisco started to host the San Francisco Cocktail Robotics Grand Challenge. Starting in, I think, 2013, 2014 is the first year we were involved. Me and a couple of my friends who were programmers and electrical engineers decided we would create entries for this. And our first robot was just a nightmare. It had an electrical quirk that caused it to open all the valves at once and just pee all over the table, just all sorts of booze in all sorts of places. And we were very embarrassed and thought to ourselves, we got honorable mention though for most honorable failure. Which I was like, all right, at least I have a good sense of humor about this. Like, all right, okay, but we can do better. So we spent the next 10 months in the garage, like, you know, all of us working full time, but then on the weekends we'd go and hack on stuff. I got a TIG welder, welded a whole aluminum frame for it. We rebuilt it all the way from scratch and built our first cocktail robot as a team. We've built 3 now. This one was called Inebriate, and it serves 31 ingredients. You can order online from your phone. It announces the name of your drink. It's very showy and fun. All the bottles are inside, and you can see them. They're inside a big clear front container, polycarbonate front. And there's a thing that moves back and forth on a vacuum chuck, and there's stirring and ice. It's a show. It's very fun.
So are you doing this for fun on the side while you're still doing the other? Yeah,
it was our weekend hack. Like, it was just 4 of us getting together on the weekends, you know, building robots by day, grilling chicken and having dinner and playing, you know, board games at night. That was kind of our MO. It was really fun. And my boss at work said I could use the machine shop on the weekends as much as I wanted, which was brilliant because it meant that I got extra training for free, and he paid nothing for it because I was using either scrap materials or my own materials. And so I got way better at machining, building all this stuff.
Awesome.
And so we built that one. Then we built our second one we called the Blaster, and it uses a facial detection algorithm to fire a shot of liquor into your mouth from 3 meters away. And that, I mean, honestly, the hardware on it's relatively simple. The software is much more complex. I have one.
You're a hero.
It's in San Francisco. We built it in 2017. We won our 3rd consecutive first prize in the cocktail robotics competition. At that point, we were kicking ass. No, we were kicking ass and taking names and winning first place.
Wow.
We won 3 years in a row, 2015, 16, and 17. And then that one ended up with because it's using a camera for facial detection and it knows the timing, it will take photos and videos of your reactions as you get hit in the face with liquor.
Nice.
And our front end guy is amazing. And he built an entire system where we custom generate a site so that you could then download or upload your media from there. Just beautiful stuff. And 2017 was the summer when I stopped working at Nano Precision and ended up going to get my MBA. I got to backtrack a little bit here because there were several things going on at once. I also thought maybe I would be interested in intellectual property. And so I sat for I sat for the US patent registration exam and passed it, the patent bar.
Wow.
So I'm a registered US patent agent as well. I started doing patent work like within the company at Nano Precision, and it was cool, but it was clear that I am not meant to write patents. I don't write very quickly. I don't like sitting still very well. The patent world is about sitting still, and I am not. So I thought, gosh, where can an extrovert who's also an engineer go and find fun? I'll go get an MBA. So I did better than expected. After the patent bar, the GMAT's not so bad. I did better than expected and ended up at Chicago booth.
Nice.
And so went in 2017 after having just won third consecutive cocktail robotics competition. You can imagine what happens when you show up with a robot that shoots liquor at people to business school.
You're everyone's best friend.
It was incredible. Within 72 hours of orientation starting, I had made something of a reputation for myself. And I mean, like, I thought, like, oh, this will be fun. Everyone's coming in with something cool. You know, like there's an NFL player in my class. Everybody was like, dude with the robot. Okay. So it was awesome. And I spent 2 years there really doing business stuff, focusing on entrepreneurship, tried to spin the shot robot into a company. My technical co-founders were all full-time employed, making good money. They chose to stick with their full-time gigs and didn't really want to quit to shoot people in the face with liquor.
Lame.
I tried. I did my convincing, and they weren't convinced. And my business co-founder had to go take a full-time job for immigration reasons because America. I know.
That place.
I know. So that was the biggest bummer. So I ended up without co-founders. And I was like, I'm just not jazzed about having a company by myself. And
because you're an extrovert. Interesting.
Because I am an extrovert. I need humans.
Wow.
And so when a friend of mine came to me and said, hey, why don't we start something in Berlin doing smart furniture? And she's a longtime friend of mine. I said, that sounds awesome. You mean we can put robots? We can put robots inside beds? Sign me up. So I moved over here to do that, to start that with her. She's a furniture designer by trade and an interior architect. She's brilliant at it. And we started building my second company, Wrinkle.
So do you still have the other company or? No,
D20 Robotics, as we called it, named after the famous die. Because we played Dungeons and Dragons together, we named our robotics company after on a D&D reference. Yep, we're that cool. Wrinkle I wound down D20 before coming here. And so Alyssa and I worked on Wrinkle for about a year. We built a functional prototype of a canopy bed. So a bed with legs that go all the way up and connect over the top. It was just a very standard, like kind of the princess bed that you think of, like fairy tale bed with the 4 posters and the thing over the top. Imagine a modern reworking of that is way sleeker and more sexy. Thin metal legs connected over the top. And I built a track system that fit inside of the legs that allowed the bed to stay horizontal but move all the way up to the top. And then there was a desk nestled in underneath that could go from sitting to standing to all the way up. So cool. You could take, if you have I have a tiny apartment and I had to get my bed out of the way. And so this helps create a whole lot more space without you having to have high ceilings because you're not in the bed when it's up. And so you can take your tiny apartment and get multifunctional space out of where the bed, which has been traditionally pretty much dead space. And you could sleep in a real bed that's full size,
Yeah.
like a normal human being. You don't have to have a tiny little cot. You don't have to have a Murphy bed that folds up. None of that. And so we built a prototype that was starting to work, and she had some personal stuff come up and was unable to continue. So then I once again found myself in a startup as a solo co-founder, and the pandemic was midway at that point, and I was just kind of not in a space where I could really continue.
Wow.
So I started freelancing at that point. Of course, I'm over here in Berlin. I am not German. My network isn't really here. So it was a tough first year of freelancing.
I bet.
And did a couple of cool projects, one of which in San Francisco, a moving set of shelves for a bar that I believe should be opening soon. One of the judges for the cocktail robotics competition remembered me and said, I know a guy who could build something. And it's a set of display shelves that are tall, 6 meters tall, and they move around on a chain system. There's illumination.
What?
Yeah, they're super cool.
Do you
So
have
it's
pictures
like
of this?
massive. I only have pictures of what I've done. They haven't sent me photos of the finished product yet because the carpenter had to come in and build all this stuff. The lighting guy had to come in and put all his lighting stuff on it. I'm waiting. I'm
You
so
need
excited.
these for your profile.
I need them because it's so cool, and it moves. They have half of the shelves move fast enough that they can get bottles down from the top. So like the top shelf stuff is literally way the hell up there, and you press a button and it comes down to you, and it's all balanced and it rotates, and it's all on giant like motorcycle chain stuff.
Oh my gosh.
The
Strike that,
opposing-
you need video of this.
I have video of it, and the opposing wall is even cooler because what they said is we want something where somebody comes in, has a cocktail, doesn't notice the shelves moving, and when they look up, all different bottles are on there, and it's like magic.
How
They
cool.
have to move so slowly that nobody notices it. And so I built the exact same system with the delay, and it takes it like an hour, 45 minutes or an hour to make a full revolution. So it's going really slowly.
Oh.
And so I have time-lapse photos of that. And so you can see me like moving around, getting it installed, and it starts to kind of creep around over 45 minutes. It's really cool.
Neat.
It's really cool. And they're
It's
massive.
difficult for the bartender, but it's really cool.
Well, so this bar is built to show off. They have a selection of antique whiskey bottles that are empty.
Ooh.
And so they are there to display these bottles. And so they have custom lighting built into the shelves. There was a whole to-do about how do you get electrical power to a shelf that's on a moving system.
Yeah.
It turns out that was certainly the most difficult challenge there.
Really?
The motorcycle chain is conductive, and so I'm using that to pass DC.
Oh my gosh.
Yeah, and then I had to have bearings that were conductive. Turns out ball bearings don't conduct super well, but plain bearings do. You got to use conductive lubricant. It just like
See, that's some
every
niche
part of
knowledge,
this.
you know, that no one else
That
probably.
is the weirdest, like outside the boxiest sort of stuff.
Which bearings are
And-
conductive? Will knows. Is
Yeah.
there like a rule of thumb when you're looking for that you know now? Is
It turns
certain
out conventional
materials?
brass bearings, the plain ones,
Yeah.
work great, but
Wow.
ball bearings, terrible.
Oh wow.
Yeah, and ball bearings I would love to use because they hold more load, they move more smoothly, they don't make any noise. Like
Yeah.
it'd be great, but nope,
But
plain
no.
bearings.
That's a thing I know now. Thank you.
Yeah, and it all had to be welded in place. They set me up with, so I did all the design work in Berlin, then I flew back to San Francisco for the install. And they gave me a team of metal workers when I showed up, and McMaster Carr showed up with $2,000 worth of bearings and crap. And it
Wow.
was fortunate. Like the design worked, you know. It
So this
took
is
me a
just
while to install it.
one custom installation.
That was a single project. Yeah.
Wow.
That was my big project of 2021 as a freelancer.
So must be some fancy whiskey bottles.
It's cool. I undercharged them radically, which was a mistake. But and when I came back from that trip, so I got back in July, someone in the co-working space where I am said, hey, we're looking to subcontract out. We're an engineering services company. We're looking to subcontract out some mechanical engineering. Anybody know anybody? And my name came up, and so they picked me up to freelance on this project. And I don't know if I'm allowed to disclose it, unfortunately.
Then don't. But
but I started freelancing for them. They said, actually, are you available full time? I said, yes, but I like business also. And they said, well, We're based in Belgium, but we want to start the Berlin office. Do you want to be on the business development side plus also the engineering side? So I took a full-time position with them. So I'm now doing that. I have a non-compete, so I'm not doing freelancing anymore. So, well, I can do freelancing of stuff that's not in their core business. So like I'm still coaching startups that are here and that sort of thing. But
can you say what their core business is?
Yeah, it's engineering services. They do mechanical engineering. So it's all of the stuff that I was already doing. It's all of the stuff. Well, but it's already stuff that I was doing anyway. But now instead of just being me, it's a team of 25 engineers, rock star engineers in Belgium, and then 2 of us in Berlin holding down the Berlin fort. And so they can do stuff that there's no way I could have done as an individual engineer. And they have project management stuff in place and clients, like client management stuff, so they can make sure everything moves smoothly. It's nice to be on a team where everything's kind of organized and everything. And if I need someone that does simulations, it's like, it'd be great if we had simulations. Like there's 2 guys who do just simulations.
Nice.
And they are incredible, right? And if I need renderings or sketches or that sort of stuff, there's the renderings and sketch people. Because my robots, as fun as they are, never look good. They always look very mechanical. Like there's an aesthetic to it. I put round edges on it, but I have no eye for product.
What more do you want? The edges are round.
It's lab equipment. It's fine. It's not going to cut you. It's okay. And so they've got people that do product design and that sort of stuff. So it's nice to be on a team that runs kind of the full spectrum, and it's still almost exclusively mechanical engineering. They get into electrical and some embedded systems and that sort of stuff to make stuff work, but it's not, and board and PCB layout, but nothing like hardcore electrical engineering. I guess that's hardcore electrical engineering. That counts. Yeah.
And where are the clients usually?
Mostly they are in Belgium and the Netherlands. We're branching into the German market, and the goal eventually is I would like to move back to the US in the 2 to 5 year time frame, and then we would then branch into the US market from there. And so if we start building up a US client base, that's nicer for my mom because she gets to have me move home sooner. Yeah. So that's kind of the end goal. That's the direction that we're kind of taking it. But I think honestly, all of the projects that I would take as a freelancer would be appropriate here also. And so it's kind of a tricky thing to figure out if it makes sense. Like I don't know how that would work with Odd Engineer. Theoretically, my non-compete doesn't extend to the US, but I also don't want to be working behind the back of my brand new employer.
Yeah. Yeah, I mean, you could be just leaving it up as you are that's
yeah, I think I have Voxdale GmbH up there.
Voxdale.
Yeah.
And that's the company you're working for. That's not your own company, right?
That is the current company. That's the real deal, peeps. I mean, Will Fischer Consulting was the real deal also, but yeah.
So people could get in touch with you to talk
Absolutely.
About in English. Hey, native English about what that company could do.
We offer services in English and Dutch primarily, but if you need German or French, we can probably make it happen. I'm sure somebody in the company must speak some random other language somewhere.
Very cool.
Yeah, so most of the operation, Voxdale is primarily located in northern Belgium, which is Dutch speaking. And so that's their main office. So most of them are Dutch speaking. And my office mate here in Berlin is Dutch, and so he of course is also Dutch speaking. Nice. I'm also often ashamed at how much better their English is than mine. So that's the other side of it.
So, I mean, you just rattled off a bunch of things that you've worked on. You said this stuff is pretty similar to that, but can you just give a rundown of what kind of, like, if I were a startup, to see if my project were appropriate for you?
Well, startups are something of a specialty, actually. They have traditionally worked really close with the startup communities in Brussels and Antwerp and Ghent, which all have universities and all spin-off startups. And a lot of times they collaborate with startups coming out of those universities. So that's very much the classic bread and butter for this engineering company, which I really liked. When they said that, I was like, these are going to be my type of people. But a lot of it has to do with product design. You know, somebody will come in with a technology, whether it's coming in from academia, where they've got like academic, like, we know this, we can make this thing happen and it's crazy. Or they come in with an idea and say, you know, we've got the code to run this thing, we need the hardware to run it on. Or they come in and say, we got this crazy idea, like, we want to build this thing in the cannabis industry and we need somebody to engineer this crazy thing, or whatever it is. So like, yeah, I'm working on, like I said, a project right now that's in the cannabis industry. That's a product, it's a household product. It'll have to go through both, probably go through medical regulatory and consumer electronics regulatory. We'll help them with those applications. I'm working for another one that's for a theme park. It's got to mix some fluids and stuff together. Yeah.
Wow.
It's for eventual human consumption. So it's very similar to a cocktail robot. And they were like, we have just the guy for this. It's like, yes, put me on that one. I'm in. I'm on it.
Are the end products always electronics, or are some things straight mechanical?
Typically. They do some straight mechanical things, particularly in the medical industry. There's some medical devices that they have that are purely mechanical. One of the companies that spun out from this has a system that allows you to collect urine samples much more cleanly than peeing in a cup, which is really nice. Nice. So they have that whole system, and it's beautiful, and it's purely mechanical.
Is it a Shiwi?
It's not far off. I imagine a Shiwi with a collection system. Nice. and basically a carburetor float to change a valve position.
There you go.
I looked at it, and like 10 seconds after looking at it, I was like, I know exactly how this works. This is the most brilliant design I've ever seen, and this thing costs nothing to make, and I hope you patented the hell out of it. And they have, conveniently. It's beautiful. It's super elegant. I never thought I'd say that about something that people pee on, but you know what? It's the glory of being an engineer is to find beauty in the weird stuff.
It sounds like you always just find the weirdest projects that are like that.
I do have a knack for very, very off the beaten track projects. And I love that. I mean, that's how I would like it to be. Yeah, and so they seem to also find similar products. You know, how do you redesign this boat hull to be faster and sleeker and sexier? That's, I think, one that we may end up pitching, and that's going to be some simulation, some mechanical design, some design for manufacture, that sort of stuff. They have people who really know metal die casting and injection molding and like high volume manufacturing stuff, which is less what I know. And so it's good to be paired up with people who are thinking, you know, ahead to what happens when we're making 100,000 or 1 million of this product. And so it's good. I think that's one of the things that having a bigger team really is nice for.
Yeah, super nice. And you're not in a corporate environment. It's still like that.
No, I mean, you can tell that like there's a whiteboard on a box, right? Like we did just move offices in fairness, but yeah, no, it's very startup-y. It's super relaxed. It's super fun. It's a good team. We give each other shit all the time, like in the like fun way. It's very like family.
That's nice. That's so nice.
Yeah. It's been really fun. It's been really fun working with them so far, and I've only been here for a couple of months.
Well, it could change, couldn't it?
Yeah. No, people are people. They'll be fine. So yeah, so it's cool, and I have a presentation of their work. I don't know. I don't know the presentation very well because I just started here, so it's going to be an adventure if I give it. There we go, Voxdale. That's us, faster forward together. Mostly located in Belgium. So,
is that someone's name, by the way? What is Voxdale?
I should know the answer to that question. I don't truthfully know.
It sounds like a type of robotic creature.
Yeah. Or like a pleasant place, like a hill and dale.
Really?
I don't know.
Oh yeah, yeah,
I don't know. So the general idea is that if you have a product where you have some level of technology that's kind of experimental or prototype phase, that we are the ideal partner to kind of help take that through prototype phase, de-risk the technology on it, and get it to market for you. And that could be highly experimental technology, or it could be pretty mundane stuff. But getting it there is kind of what goes. And Voxdale takes a very collaborative approach. I don't know if this is going to be in a slide later, so we'll see. Maybe. We'll come back to that. A very collaborative approach, and really likes to work with the team that we're with. So if there's engineers that are already at the company working on stuff, we like to make sure that they're included in our calls to make sure that that their technological development matches what we're working on as well.
Yeah, that's
so we pull the technical teams together, because nothing is more frustrating than being an engineer, having the business persons hire out engineering who doesn't know anything about it.
I hate that.
Everyone here hates that too. We want to make sure that the technical people are communicating with technical people.
Beautiful.
That's really important to us. And if there are no technical people on the other team, then we are happy to spend time explaining what we're doing and how it works and why the things we're doing are difficult. And I have been impressed with the caliber of the teachers that exist on the technical staff here as well. People are really happy to slow down and make sure that people know what's going on.
That's great.
Which I think is a strong sell for me personally. So yeah, the idea is that we kind of help get products to market. We can do a number of different things, designing products, or all the way from concepts, products, so on. We can help and do design reviews specifically, due diligence also for kind of patent research and competitive landscape stuff. With intellectual property, we can help write up. I know for a client, I wrote up a list of what I felt were patentable technologies, which I do have a background in that, so I can really go in and say, like, I built this thing, patent all of this crap. And we can also do a lot of, the company actually started as a simulations focused company. It's moved on because what they found was that the clients really were looking for more than just simulations.
And what kind of simulations are that specifically? Is it
mostly
and thermal?
Fluids, thermal, and stressy, like structural things. So all in the mechanical realm. Windmills, boat hulls, race cars are on the fluid side, but then also tiny things, electronics enclosures, heat buildup in medical needles, like all manner of crazy stuff. Like micro scale level as well. Wow,
that's so many things. But you know what? It's not. There's no optical simulations there. Will, what's up with that? I think when that comes across your plate, give Aaron a call.
Yeah, absolutely. Optical is way out of my bread and butter. So like on my project where I have shelves with lighting on it, I was like, you get 24 volt DC. That's where I stop. Like that's as far as I go. The rest is on you. So yeah, so it would be. It can absolutely keep you in mind for that.
But I don't know anyone who can do fluid simulation, so that's really cool.
Yeah, and we can do that, and also the prototyping that goes along with it. Cool. And I do think that's actually where a fair number of the clients come in. Like the cannabis industry is interested in getting stuff into gaseous form or vapor form, and so we're doing that when it comes to building things that pipe around, alcoholic beverages and that sort of thing. Then it's nice to have that simulation.
Yeah, cool.
Here we go. The product development capabilities. It's like they had a slide ready to go. When we talked a little bit about simulation, there's also a strong component of cloud and IoT stuff, how to get your mechanical data to someplace useful, and that sort of stuff. So that's there's a whole section of the company that's dedicated to IoT and cloud. We have, of course, full mechanical development, but also product development as well. And both the Belgium facility and the Berlin facility have prototyping facilities to build out full products. In both cases, there's full banks of 3D printers, but also CNCs, lasers. Here, there's also large-scale CNCs, so we can do furniture scale level stuff, get that big, but then also resin printing level of minute granularity and laser stuff there. So we can do a huge spectrum of prototyping there.
Nice.
And then also have production and industry partners to ramp and scale up.
Oh, cool. And where are those? Are they in Europe?
I think that is a good question, and I don't know the answer. I have not been with a project long enough to see that go, and so I have not experienced that. I wish I knew.
If you're doing IoT stuff, I'd love to introduce you to the guys at IoTerra, because that's what they're building, is a community for people who need connected device development, to find providers and to find just answers to little questions or full projects. Yeah,
that's fantastic. I think we have the right people for that. That's not what I specialize in.
Yeah.
But I can make sure, if you will send me that info, I will connect to our IoT guy. He's one of our PMs, and he is an extraordinarily brilliant guy.
Awesome. I mean, IoTerra is meant to be eventually like all product development stuff as a hub. But the connected device stuff is the hardest, right? Because you got the stuff that needs to be frozen,
so
the mechanical, and then the stuff that's alive that needs to always be changing to be current. So
absolutely,
I guess the mechanical is a part of it.
yes. It has, if it exists in what my programming friends call meat space.
Meat space.
Meat space. It's the space where you're
or MEAT?
MEAT. It's where your meat exists. There's, cyberspace and meat space. Those are the two your options.
Okay.
Yeah, they spend all day playing around in cyberspace, and then they want to come build stuff on the weekends in meat space. That's how we build robots together.
Nice.
Which I think is just like a delightful expression, if possibly a little crass. But yeah, so asking about fluids. Again, I'm looking through this presentation for the first time as well.
We'll do it together.
Fortunately, I know the company. But yeah, so this gives you an idea of the different things. So you have fluids up in the top left there, structural analysis and error analysis in the top right, thermal analysis. Topology optimization allows you to run through multiple iterations of the same mechanical design. So you might start here. You see, can you see my mouse?
Yeah.
Okay, perfect. It's like having a laser pointer, but in 2021. Yeah. So you might start with this thing, but you want to make it lighter. You run the optimization process, and it removes material while keeping a specific factor of safety, so that your material stays strong, and you can radically decrease the weight or material cost or so on of something that has effectively the same amount of strength as your original. And particularly when you start moving towards additive manufacturing, this becomes an extreme advantage, because you can use way less material and get the same structural characteristics out of it.
That is really cool. I didn't know that was the thing you could do.
Yeah, it's super cool, and things and being able to do that kind of in silica is a super big advantage, because it lets you iterate extremely quickly, and then you can iterate really fast in simulation, print a handful of these in the prototyping facilities that we have, and then check them alongside. And we even have a printer here that prints carbon fibers, so we can do extremely high strength materials.
That's
it's
wild.
Cool. Additive technology has come so far in the last 5 years, it blows my mind. The next 10 are going to be extraordinary, and my brain just doesn't even function thinking further than that. It's so neat.
Is the carbon fiber printer, is that in Berlin, or is that in?
That's in Berlin. Yeah.
Cool.
Yeah, though I'm kind of pushing for one being in my apartment, but
yeah,
anyway.
right?
Yeah, not yet. So far, only a filament printer there. So, okay, here's a little bit more detail on your IoT question. So kind of the different offerings here.
Awesome.
Yep.
All the things.
All the things. So like I said, I haven't worked with this part of the company yet because I'm relatively fresh there.
Yeah.
But cool stuff there. I could read those things, but then so too can you. so,
sure.
So I don't think I need to.
That's
yeah, let me know when it's good. When.
So just, I think I'll turn this into a mini podcast episode if you're cool, because we've basically
absolutely
done all the things that I would normally do. I'll just read it off.
Fantastic.
It says IoT and connected devices, and then there's the connected product strategy, going from device hardware to device software to communications, cloud platform, cloud applications. So this slide is showing the whole thing. They can do the PCB and electronics design all the way through to the coding stuff, and even the applications themselves that are on the cloud platform.
Absolutely.
So, very cool.
And we can do some of the like kind of brainstorming creative parts of it. If you have kind of like a vague idea, we can kind of help, condense that into something that really fits with this.
Beautiful. Got any more slides in there?
Oh yeah, it keeps going. We could stop whatever you want. So these are some of the markets that we specialize in. So medtech is one they've been particularly focused in, but then also we have a lot of food tech, as you see below where it says food tech right there, the Albert's smoothies and Albert's soup. Those are vending machines that make fresh smoothies and fresh soups. And so my office mate here built the original smoothie machine, which uses real ingredients, blending it on site in the machine while you watch. It's such an incredible piece of engineering, and it's such a difficult thing to do. Frozen bananas are the least consistent material of all time, and so to feed those with a consistent dosing and then blend them is not trivial. And doing that for a dozen different ingredients in the same machine, the engineering that went into this is really cool.
I would have thought it was the cleaning part that would be hard, but I guess that just
there are also self-cleaning aspects of it, and it's a bunch of work.
Cool.
There's also, they do a lot with cycling. I think part of being in Belgium is lots of love for bicycles. Or maybe it's just speaking Dutch, I'm not sure. But they do a lot there, both with the mobility industry and also then doing analysis to improve competition sports equipment. I think they also did something for the Belgian field hockey team, national field hockey team. Maybe I might be misremembering that. Don't quote me on that.
Okay.
And also in the competitive racing industries. And then Industry 4.0 is all of the IoT stuff, loading and unloading of shipping trucks, lorries, that sort of thing. I know they've worked on projects in there.
Wow, that's cool. So yeah, like I was mentioning before we started recording, like all these different markets, these industry experiences that are represented here, those to me are different specialties, because each one comes with different standards, different regulations, different expectations of all sorts of things. And if you're developing a product for one of those, again, like anyone could do it, but if you've already worked in that space before, you're going to do it better and faster. Yeah, that's super cool to have that big of a spread at Voxdale.
Yeah, it's true. And the principals who have been here for 15 years were working in the industry before that, and they bring in some unbelievable knowledge of the way that stuff works. It's really been fun. Like I'm certainly an experienced engineer, but looking at the guys who've been at it for decades longer than me, it's like awesome to just be able to learn from them. And to have their experience on board for stuff. I'm
so glad I got to meet you and learn all about your skill sets. And
I'm a strange human being when you get right down to it, but I have a lot of fun building stuff.
Yeah, so many different talents. You got the electromechanical, the patent view of things. You got medical and beverages and Germany
business
and Europe versus America, like so many different perspectives. Really, really great stuff.
You should see me write a pitch deck.
Is it good?
It's all right.
Yeah. You don't want to pump yourself up too much, but yeah, it's pretty good.
I write a pretty good pitch deck.
Oh, no. Maybe we should put that in your profile too.
Yeah. And then anytime I ever need any optical engineering, I know exactly who to talk to. I know exactly who to talk. I've been taking notes.
That's the whole point of all of this.
Yes. Grow the network the very hard way.
So awesome.
Fantastic.
Well, thank you so much for your time.
Yeah.
I really appreciate it. It was great meeting you. And I hope to talk to you again soon.
Hope so. Talk to you soon. Have a great day.
Bye-bye.
If you'd like to connect with Will Fischer or Voxdale about your development project, you can do so by going to Will's profile on oddengineer.com and directly sending a message. Or you can visit Voxdale's websites. There are two of them, one for Belgium, which is voxdale.be, B as in boy, E as in engineer, or voxdale.de for Deutschland. Thank you for listening.